What is good? What is good? Let me squeeze into my seat there. Sorry, it's like tight. I have like some food right there. Like just some like a bag of chips there, so it's like tight to get in this seat, but here I am. What's good, guys? What's good? I don't I don't always look this good, I'm sorry. But I went to church this morning and then I was uploading it. I knew I was going to upload a video today, so I was like, let me just keep this stuff on. Let me just keep this nice attire on just so I can look like pretty good for you guys for at least one video instead of me just like having like one of my collection of hoodies on or like just a t-shirt, as you guys have seen in most of my videos thus far. But yeah, so hope you guys like this. And blue's my favorite color, so I like this. Really like this button down. But yeah, and I'm a little bit zoomed in so you can't see like the front of my desk here, but you can see like this part. I don't want to show you the dirty part of my desk because you guys don't need to see that. But you can't see that. All you can see is me, this nice shirt, my like cup of water there. If you can see that in the corner, my papers. So we chillin', good stuff. So in this one, hopefully you guys had a good break day yesterday. Saturday I didn't post. Hope you guys had a good day. And hopefully your Sunday's going well too. Or wherever you're watching this. Sorry, that was my phone over there. But yeah, in this video we're going to discuss the von Neumann architecture and the stored program concept. So this is just straight like computers video. So this isn't, we talk about different stuff on this video. And my technology videos, I do have a playlist for that stuff, so hopefully if some of you guys are interested in that, we're going to talk about that. And I may talk about more of some of this stuff because I am a computer science student now. As of this semester, I am taking classes at community college. Maybe I will transfer. This is like, I'm in an intro class right now. And obviously I've been studying on the side for a little bit, so this is kind of exciting to me. Sorry if I do sound a little bit tired. I woke up early to go to church today and I haven't taken a nap yet. So, and then I've had like some family stuff going on, and then I like called some buddies. Like I called my buddy. So, I'm definitely up. So sorry if I sound a little bit tired, but we'll continue. And the script is long, so let's get into it. So what's good, people? Hopefully you're enjoying your Sunday. Today we're going to discuss the von Neumann architecture, one of the most important, if not the most important, concept in modern computer building. So I'm not going to cover all of the aspects of the von Neumann architecture today, as that would be literally impossible. Even if I wanted to do that, it'd be impossible. This concept is around 80 years old now. I think it was in the 40s. It was in like the early 40s when they were making those first computers, like the ENIAC computer. This is when they figured this concept out, or they recognized what computers could be, like when they were building that first computer in the 40s during World War II. So that's how old this concept is. And it serves as a foundation for a lot of things that you experience with computers today, because they built like the first modern computer, and many of the, like basically all of the modern computers after that, they followed this von Neumann architecture. So that's what we're going to discuss today. So first of all, who was von Neumann? Well, I cannot discuss the whole life of this man in this video. That would also be something that would be impossible to do. And furthermore, it wouldn't even be proper to do that because I did not know this person. This person, I believe, was deceased before I was even born. So I didn't know this person, obviously. So I can't discuss all the things of his life. And if you want to know more about his life, definitely go Wikipedia him, or there's probably a lot of ways you could figure it out. And technically, John von Neumann, which is his name, he's not necessarily the only one who developed this concept, but it's named after him. And he was a genius, and he was a big part of how we understand this concept today. So that's, it's called the von Neumann architecture, like they named it after the guy, so he was important in developing it. But So I can't tell you all about his life, but what I can tell you is his name was John von Neumann, and his work was huge in the early history of modern computing. So the von Neumann architecture is based upon the idea that both data and the instructions to manipulate the data are logically the same and can be stored in the same place. So you guys probably should have a little bit of an understanding of computing before watching this video. Because I can't tell you about I'm not going to go over binary and all that stuff. I'll go over it a little bit in this script, but I can't tell you, like I said, I can't tell you everything, man. Like, this video would literally not end if I were to tell you, like, literally wouldn't end, and we can't do that. So, because this is only one channel and I'm only one man. But, so, the data and the instructions to manipulate the data are logically the same and can be stored in the same place. So what is data even? Well, technically, that's up to you, so that's the funny part. The definition of data is up to you. But in modern computers, data is represented by bit patterns. And these bit patterns are obtained by the physical movement, or lack thereof, of electricity. So if electricity is allowed to move, that is because you've probably heard of ones and zeros in binary. So if the electricity is allowed to move, that's a 1. And if it's not allowed to move, that's a 0, to put it basically. So, or to put it simply, at least that's as far as humans understand it, because how much do we understand just the physical world around us? You could argue that, but that's as far as humans understand it. And I'm talking about the computers that we use today. So I'm not talking about quantum computing, because quantum computing could render this whole video and topic irrelevant, or maybe not. It would at least render some parts of this video irrelevant, but we're not going to get into that. It's all good. We're not going to talk about quantum computers today. So moving on, talking about modern computers. Another major characteristic of the von Neumann architecture is that the units that process information are separate from the units that store information. Okay, so let's go over that. The data and the instructions that are used to manipulate the data are logically the same, and they can be stored in the same place. That's the first tenet. And then also, the units that process the data are different from the units that store the data. So that's the second tenet. Alright, knowing those two things, go build your computer. Okay, end of the video. Go build your computer, you're welcome. No, I'm just kidding. I'm kidding. But feel free to go and try. Actually, you'd be in the same boat okay, I'm a nerd. So I said you'd be in the same unit as me if you want to go build your computer knowing that information. But I'm just kidding. I'm just kidding. Technically, I am a first-year computer science student, so bear with me. That's why I'm making these bad jokes. And also, I'm a nerd, if you couldn't tell that from like the 2.5 years I've been doing this channel. I'm a nerd, so if you could not tell that by now. I'm 26 years old currently, and my name is Romy. I just put that in the video just to be funny. I'm a nerd, so how funny can nerds be? Not very funny, apparently, because there's no laughter in here. But then again, I'm the only one in this room. So anyway, modern computers generally have the following 5 components based on the von Neumann architecture. So they have the memory unit, which holds both the data and instructions, because they can be stored in the same place, right? So they're stored in memory, the data and the instructions. They always call it arithmetic. I don't know. I thought the word was arithmetic, but I just hear arithmetic a lot, so I'm just going to say it the way they say it. The arithmetic and logic unit, or the ALU, we'll call it the ALU. So that unit is capable of performing it's arithmetic, dude. I don't know why people say arithmetic, I've heard arithmetic and arithmetic. I don't know why people, that's an E, not an A, but it's all good. So that unit is capable of performing arithmetic and logic operations on the data. So logic operations are like and, or, not, and those kind of things, which, if you're computer science or like a probability math kind of person, you're aware of those things. And hopefully, dude, this video would be so long if I had to explain all of that, but like those are gates that are those are used to build your computer essentially. Like those transistors are used to form all of these units. So those logic gates are in your like hardware. So the ALU is capable of performing arithmetic and logic operations on the data. The input unit, that's the unit that moves data from the outside world into the computer. So you could call that your keyboard. This could be punch cards. This could be your mouse. Those could be like honestly so many things now, like all these sensors and stuff. And the Internet of Things, like inputs are going to be a lot. Like there's going to be a lot of things that anything that can input data into the computer is an input unit. So that's the third unit. The fourth unit is the output unit. So that moves results from inside the computer to the outside world. And like the most classic output unit is like a printer or like a display, just like a regular computer monitor. So that's the output unit. And then finally the last unit is the control unit, and that serves as the stage manager to ensure that all the components act in concert. That's like the orchestra leader is the control unit. So you could call the control unit the brain of the computer. But then if that's the brain, what would be the spinal cord? So the spinal cord would probably be represented by the bus. So the bus is basically just a set of wires that connect all of the components inside of a computer together. So the reason they're wires is because in modern computers, they run off of electricity. So modern computers, they use the presence or lack thereof of electrical pulses. That's what we use to represent data. And then you use those pulses. If there's a pulse, that's a 1. If there's no pulse, that's a 0. And then that string of 1s and 0s, as like the electricity is pulsing through the elements of the computer, that determines, like, that's the bit pattern. And like that bit pattern that represents the data. So that bit pattern is what is the physical data. And then from that bit pattern you can apply basically an interpretation to that bit pattern, and then you have like what we as humans can perceive as data. But the machine just thinks of those electrical pulses and that bit pattern. That's data to the machine, and that's what the machine works with. All we as humans, we just take those electrical pulses, we record the bit pattern, and then we apply an interpretation to that bit pattern, and then we say, okay, this means this. So the computer has this, and like we can just say that means this, and then like we can store it. So whatever the bit pattern was, like we store that in the computer's memory. So whatever the computer did, the computer remembers what it did. It's difficult to fully explain and to fully honestly understand. Like it took me a long time to understand this. So, it's hard to say it in one video. But so that's why like I would call the spinal cord the wires that connect the components together. Technically, a computer doesn't have, like, this is the way we make modern computers. That's the application of these concepts. Computing system, there's just a lot of ways you can create a computing system, but the most cost-effective way that we've basically determined how to do it, and like the most cost-effective and like space-effective way to do it is kind of the way that that's the way that we're doing it now, is the best way that we've figured out how to do it. So that's why like the bus it's a set of wires that passes the bit patterns to and from the components in the computer. So like whether it's the memory unit, whether it's the control unit, or whether like you're inputting data or outputting data, the like pulsing of electricity is what determines, like, that's the information that the computer has. It's the pulsing of electricity, and then we apply an interpretation to the pattern of pulses, and that's like information. Like that's information. That's modern computing. So yeah, so the bus is the set of wires that connect all the units together, and I would call that the spinal cord of the computer. So yeah, I went a little bit off of script there, but that's like a better way to say it than what I wrote in my script. So yeah, so these wires are generally inside the box that you plug into your wall. So like usually when you build a PC, like you put all these things in a box usually, and like that's like these wires are, and all these components are usually inside that box. Or if you have a personal computer like this laptop I have on my desk, all these components are inside of this laptop. If you have a phone, like most people have phones these days, these components are inside of your phone. Like if you have a car, there's a computer inside your car. Like there's probably multiple. If you honestly, like with the Internet of Things, we're gonna have a lot of computers in a lot of places. So that's what modern computers are. Like they're a bunch of wires that they use electrical pulses or the lack thereof in order to communicate with all the units, and like we call those bit patterns, and then we apply an interpretation to those bit patterns, like the ones and zeros, like the pulse or lack thereof electricity, and then we just call that data, and then like we make all this software and all that stuff, which I won't get into, and that's technically what I'm studying in school. But yeah, man, like sorry if that's super confusing, especially to those of you watching this channel, but that's computing, man. And yeah, so I'm just gonna stop there for now because this is a YouTube video on my YouTube channel. There are other videos that explain this better and even have diagrams that would help you understand it. Or to be honest, you could even read a textbook or talk to a professor. Or you can listen to me more as I begin to understand it more. Or you could even tell me where I'm wrong, man, because some of you guys might know this more than me. Or you could talk to a professor, or you can speak with Bill Gates, man. I would love to do that. You could talk to Bill Gates, and then you can tell me what he says, or you can introduce me to him. That's so funny. Like, I almost like might have probably kind of met him maybe, but unfortunately I screwed up that opportunity. So hopefully, like, I don't know. But then the girl might have been lying, because like there was some girl that told me she knew somebody who helped Bill Gates get like some land or something, or like was like a writer for like something, like some legal writer, and like something about Bill Gates getting land, and like I didn't know what she was saying fully, but either way, I'm not really talking to that girl anymore. Like I don't even know if she's telling the truth, but I was super nerding about Bill Gates that day, and she brought it up. So like, but either way, I probably screwed up that opportunity anyway. So like, I mean, whatever. But maybe there might, through some other twist of fate, I might meet Bill Gates. Who knows? I don't know. Like, who knows? I don't know. Whatever. But yeah, hopefully I get there one day. I put that in the script. It's all good. But yeah, healthcare network, healthcare network, healthcare network. Trifecta. I put that in the script as well. Because that's ultimately the reason I kind of started this channel, and that's kind of like what I'm still trying to do. But, you know, hopefully computers help me with that. So we'll see. I mean, we'll see what happens. Technically, they already have, you know, so, like, I guess just let's see if we can make it more fancy, I guess, now. I guess that's the goal now. Make it more fancy. Make it more modern. Like, update it. So, yeah. Yeah, then that's the video today. I don't know how long that was. But I can't see that timer. It's all good. I think it was like we're at 16 minutes or whatever now. If you're watching this still, you're a trooper. Hopefully you liked my nice dress. And yeah, I'll catch y'all in tomorrow's video, because I'll try to be posting more frequently. And thank you guys for watching those last couple. The impressions are moving up, so looks like we're in good shape here. And yeah, that's it for this one. All right, peace out, guys. Stay healthy.